this lecture I will take some exercises on integration. Let's start with some simple problems involving the basic formula of integration. Okay, let's say integration of 6x to the power 3 dx. So in integration, first of all, the constant remains as it is, that is 6. Now x to the power 3, that means we are raising the power by 1. So we raise the power by 3, it becomes 4, and it is divided by the same power. And we add the constant of integration, which is c, because this is not a definite integration, it is an indefinite integration. Okay, so now we just have to simplify this. 2 2's 4s and 2 to 3, 2 3's is 6. So this becomes 3 by 2 x to the power 4 plus c. Okay, let's take another example. 5 x to the power 9 dx. Okay, so 5 remains as it is. 9 x to the power 9 will be, we raise the power by x by 1, that means it becomes 10, and we divide by a 10 again, plus c. So 5 goes into 10 2 times. So it becomes x to the power 10 upon 2 plus c. Okay, what happens if x is in the denominator? Let's see if 5 and x goes to the denominator as, let's say, x to the power 4 dx. So we can write the same as 5x to the power minus 4 plus c. So we have to bring this expression, if the expression is not in the form ax to the power n, ax to the power n, we will bring it to the form, now it is of the form ax to the power n. So now n is equal to minus 4 and a is equal to 5. So this becomes 5 and this becomes x minus 4 plus 1 becomes minus 3, and we divide by minus 3 plus c. So this is equal to minus 5 by 3 x to the power, or we can take x to the denominator. This becomes the answer. Okay. So let's take some example now on, this was indefinite integration where c was the constant of integration. Let us take an example where we have a definite integration. Let's say from 1 to 3 of, say, 5x squared minus 4x plus 3 whole dx. Or let's take a more simple one first. Okay, let's take integration of 3x dx. So 3 is a constant, then I will put a square bracket for the integration. So integration of x is, x will be raised by 1, power will be raised by 1, increased by 1, so it will be 1 plus 1, that is 2. So this becomes x squared, this becomes x squared, and we will write the lower bound and the upper bound limits as 1 and 3 outside the box brackets. Okay, now how will you evaluate this? This will be 3, so we'll take the upper limit, that is 3. So 3 3's is 9, so this becomes 9, and we will subtract it from the lower limit 1, and we'll substitute in this x by the lower limit. So it becomes 1 squared, so it is 1 minus 9, which is 9 minus 1 is 8, 8 3's is 24. Okay, we can do similar problems if we have a from 2 to 3, say, or let's say 0 to 3. Let's say 4x minus 5 this time and dx. Now it has two terms. The process is the same. We will find the integration of this and we will find the integration of this. So this becomes, we will put it like this for the integration. Now integration of 4x will be, x will be raised by to the power 2, because this is 1, 1 plus 1 is 2, and divide by 2. So this becomes 4x squared divided by 2 minus 5, and since this x is to the power is 0, so we'll raise the power by 1, so it becomes x to the power 1 by 1, so it becomes 5x, and we'll write the upper bound and the lower bounds here, and then we will separate the 2. Okay, so this becomes 4 into 3 squared. 3 squared is 9, so it is 9 4s is 36. 36, so 4 into 3 3s is 9 upon 2 minus 5 into 3. 5 multiplied by 3. Now since x, this will be substituted with the lower limit. So this is 0 minus 0. Okay. So this is 36 divided by 2 is 18 minus 15 in this box bracket. And this is 0 in the second one. 18 minus 5 is 3. Okay. So this is how you evaluate definite integral problems. Here there will be no constant of integration because for both the limits are there. So the constant of integration will cancel off. Okay. So in the definite integration, we do not have a constant of integration, but we have a definite answer. Okay. So what is suppose we have between 1 and 5 and we have a constant, say b, and we integrate with dx. What should be the answer? The answer is so this b is a constant of integration, right? And integration of dx will be x, because this is x to the b into x to the power 0. It is the same as writing b to the x to the power 0 dx. So when you integrate x to the power 0, it will become x. So the answer is b with x and between the limits 1 and 5. So it becomes b into 5 minus 1, which is 4b. Suppose, what do you have if I have, say, limits of c to d of say, let me say m dx. Okay. So here m is a constant, so we don't have to touch the m. And since integration of dx is again x, so I will be writing x and the lower limit and the upper limit, that is d and c. So this will be m into the upper limit minus the lower limit. So this will become m into d minus c. Okay. So now let's take an example on integration by substitution. So if I have an integration like this and I have, say, 5x plus 2 to the power 3 dx. Now, how do I integrate this? We will substitute this with something. So let's say we substitute by u. So u is equal to 5x plus 2, and then find the differential of this. So du by dx is equal to 5. X is, if you differentiate x, it is x to the power 0 minus 1. X to the power 1 minus 1 is 0, that is 1 by 1. So x to the power 1 minus 1 is, it will be x to the power 1. So 1 into 5 into x to the power 1 minus x to the power 0 is 1. So 5 remains, and this will be 0. So this is, answer is 5. So here what is dx equal to? Dx is equal to du by 5. Okay. So we will be substituting dx and u instead of this expression. So this will be having 5x plus 2 is u. So u to the power 3 and dx is du by 5. So we have everything in terms of a u now. So now this is very easy, and it is of the form of the basic form of the integration. So this will be u to the power 3 plus 1 is 4 by 4 into 1 by 5. And since this is a indefinite integration, we add the constant of integration. So it becomes u to the power 4 upon 20 plus c. We resubstitute u with the original expression, that is 5x plus 2 to the power 4 upon 20 plus c. Okay. Let's take another example on substitution where involving fractions, and in this fraction the power of the numerator is 1 less than the power of the denominator. Okay, it's something like this: x squared upon x cubed plus 5 dx. So here we will substitute u is equal to x cubed plus 5, because if we differentiate x cubed, we'll get an expression in x squared that should cancel with x squared. So here du by dx is equal to 3x squared and 0. So what is dx equal to? Dx is equal to du by 3x squared. So now we just have to substitute. So x squared remains x squared. This will become u, and dx is equal to du by 3x squared. This and this cancels off. So we get a very simple expression. Since 3 is a constant, 1 by 3 is a constant, we can take 1 by 3 outside the integration sign. So it is du by u, which is of the form, which is of the basic form dx by x equal to ln of absolute value of x plus c. So the answer becomes 1/3 ln of absolute value of c plus c, and we substitute the value of u, which is x cubed plus 5 plus c. Okay. Okay, let's take another one where which is a quite lengthy one. So I can have 5x to the power 5 plus 4x to the power 4, or 5x to the power 5, 6x to the power 5, 5x to the power 4 plus 3x squared plus 2, and or I can have dx. Okay, this is very simple, where we have a long expression but of the basic form, and we have to integrate each one of them separately. So the first integration of 6x to the power 5 will be 6x to the power 6 by 6 plus 5x to the power 4 plus 1 is 5 divided by 5 plus 3x cubed by 3, and integration of 2 is 2x, and we add the constant of integration. So 6 and 6 cancels, 5 and 5 cancels, 3 and 3 cancels. So we are left with x to the power 6 plus x to the power 5 plus x to the power 3 plus 2x plus c. Okay. Let's solve one problem on integration of parts. Integration of, say, x ln of x dx. So the first part will be u, which is ln of x, that is a logarithmic part, and the second part v will be equal to x d of x. So we are going to take, dv is equal to x. Let's take one problem on integration by parts. Integration of x ln of x dx. Okay, so we'll take the first part as u, which is equal to ln of x, and the second part, that is dv, will be equal to x d of x. Okay, so we are going to differentiate the first part. So du by dx is equal to 1 by x, and integrate the second part. So integration of dv will give us v. So v is an integration of x will give us x squared by 2. Okay, so we get the du by dx, we get the v, and you have to substitute in this formula. We get u dv is equal to uv minus integration of v du. So what is u equal to? We know that u is equal to ln of x, and what is v equal to? We got it as x squared by 2. And since this is complete expression itself, nothing is to be done further on this one. Now we go to the second one. So this is equal to x squared plus 2, and we know that du is equal to, where is du? du is equal to dx by x. dx by x. This x and this x gets cancelled off. So we get x squared by 2 ln of x minus integration of, since this half is a constant, we can take half outside the brackets and this becomes a simple integration problem, that is x dx. So the answer is x squared by 2 ln of x minus half x squared by 2. So the answer becomes x squared by 2 ln of x minus x squared by 4. And we always add the constant of integration because it is a indefinite integration. But if a limit is given, let's say from 0 to 2, then in this expression we just have to have two brackets, nothing else changes. If it is a indefinite integration, we add plus c. If we have a definite integration, say let's say 0 to 1, we just have to evaluate this without the constant of integration. So we just substitute the value of 1 instead of x here and x here. So it becomes, in this case it becomes x squared is 1, so it becomes half ln of 1, okay, half ln of 1 minus 1/4. Okay, so this is the answer. So these are all the exercises on integration. Thanks for watching. Thanks for watching till we meet in the next lecture.